Hello and welcome. So for today I have prepared another topic which is about how you can integrate an external source code in Simulink. This is a very welcome skill to have when working with Matlab, Simulink Stateflow and the real-time workshop from Madgwick. So, in order to have better understanding, I will go with an practical example. Okay, you will see what it's about. So, let's open the model first. So I have here a Simulink model which has only an input and an output. So the data type of the input, it's a structure, and basically this input collects all the data from the gyroscope and accelerometer. Yes, so you can watch my previous videos about this. It's basically an input which has an MPT signal with a structure as a data type. Yes. Okay. And then we have an output which just for visualization purpose we will send this data via Word. Inside this model we have some other blocks which handle different requirements. So we have a calibration block, we have some conversions, then we have the smoothing, which are some filters. Here you can implement something to reduce the noise of the raw values, and then we have this state estimator block, which will be our focus for today. So it's not very complicated, but here we have some options that we can choose our custom filter, which is explained in other video, Madgwick and the Kalman. Yes, so for today we will work with the second one, which is Madgwick. Okay, so inside this we have the implementation of these algorithms, which is this one is the first one, this is the Madgwick one. Okay, so inside this block we will have an S function builder. Yes, so there are many ways how you can integrate your external custom source code into Simulink, but for today we will use this block and we will explain the basic settings that you need to do in order to have it working. Okay, so as we enter in the block we have the data properties, the input ports, which are these ones, yes, the 3 accelerometers values and the gyroscope for each axis. Then we have the output, which are the quaternions, yes, this is the output of the Madgwick function, yes. Okay, then we have the data type attributes, which in my case I'm working with float, so I will keep this as double. Yes. Then we have the library. So this is an important step. We have the library where we need to specify the source path and include path. So this here we define the source, the C file in our case, and the include, which is the header. Yes. Then we have here the also type the name of the file. Then we have the include, yes, where we include the file which is located at this path, and then we have as an extend prototype here. Good. Okay, before moving on, I want to show you what function from the Madgwick algorithm we consider for today. So for this we're gonna open the system, the frame system, which is we have here an external library. We have the source, which is this one. You can find this online. It's an open source code. Good. So here we have basically two functions, which is Madgwick update for so this function, it is used if you have also a magnetometer. Yes, so this is not for today. And the second function which we'll be integrating is this one, only the accelerometer and the gyroscope. Good. So as you can see, this name here, it's exactly the name which we are going to use in the block. This one. Good. Then the source path is exactly 2 levels up, and then in external library, like so. So 2 levels up, 1, 2, external library, and then we give the path to the source code. Yes, good. Same for the include. Okay. Next setting will be the output. So here in the outputs, we just gonna call the function. Okay, so as if you take a look again in the source code, you will see the formal parameters here. Yes, and the output is here. It's a global variable, which is the quaternions. Yes, so we have q 0, 1, 2, and 3, the quaternion of the sensor frame. Good. So basically, in these global variables, yes, we will store. So from these global variables, we will store to the output. Okay. So do qt0 until 3 is exactly the output. This one. Okay. So we will save the output from the function into our output ports. Good. So this is basically the minimal settings that you need to do here. Okay. After this, we need to build the function. So we provide the S function name, yes, and we will just build the function. Okay, so we have successfully created the max one. So at this point, we already pre-built the source code. Yes. So for this, after we this, we close the block and we will go to the Matlab workspace and we will see some files here. Okay, so we have the max, that max. Then we have the TLC. Yes. So this is an option that you can set inside yes, you have here generate wrapper TLC. So basically, you know, the inline and non-inlined blocks and functions. So here we will generate the TLC for this. Yes, so just as a remark. Okay, so again, the max, the TLC, this is another C file, but our interest is this wrapper. So basically we can erase at this point and care only about wrapper.c. Okay. Of course, you need to keep the max one because you need the to have the Simulink block. So with the same configurations, so you you're not it's not a good option to delete this one max, but you can delete this one and also yeah, this one. Okay, and some other extra files that were generated. So let's open this one to see what happened here. So basically this is the wrapper which contains our external prototype. Yes, so this means that we are using an external function. Then we have here the generated wrapper, which as you can already saw in the outputs, we have called here the function and assigned to the output these values which were produced by the function. Okay, so basically this is all that you need to do in Simulink. Okay, now let's generate some code for this. Okay, so we're just gonna, I have a script here which generates code. So meanwhile, the next step would be, after code generation, to build our framework and test it. So yes, this is what we're gonna do here. Okay, almost done. So we have the report here, but we don't care for this now. Okay, so I have already copied with the script the files in the right location. Yes. So I will close Matlab because I want to delete some files, just not to take it to a build. Yes, I will close Matlab, and all the generated files that we need are here. So we have basically this one is mandatory, this one, and senseadapt.age. Then the wrapper. So I have two wrappers because I also have another integration of our custom algorithm. Yes, and these are extra files that were generated that are needed in some scenarios. So we will not focus on them. Okay, so now let's just delete some files, just not to take them. So I will delete them from here because I don't need them. They're already copied, so I don't want to have it included twice. Okay, we can keep this one. Okay, good. Now let's make a build. So meanwhile, I have here on my desk an STM32 microcontroller connected to an MPU 9255. So this is the sensor which I'm using to read the data. Okay, so okay, the build is okay. Let's flash it on the target. Good. Now let's check here in PuTTY to see. Okay, let's start. Good. So as you can see, we have the output. Okay, So let's now go back in our code to see exactly what happens. For this, um, I want to use the debug feature. Yes, so I will just close this one and start the debug mode. Okay, so I have here a 10 millisecond interrupt, which I'm using as a main function, where I will trigger the the other functions. So it's a basic check here not to call the function only when I press a button. This is for safety, because I have some problems with USB. Okay, so basically let's run it free. I will press the button and it should stop here when I will press the button. Okay, it stopped. So basically this is the sense-adapt step. It's the main function generated here. So this is the code that was generated from the previous Simulink model that you already saw. Okay, so we have here the conversions, we have sense-adapt step, which is reading the data from MPU. So this is the function which I'm included as an MPT signal to the model, which is reading the data from the MPU. Yes. Then after this, I have the other blocks, which are calibration block, some conversions, some noise reduction functions, and here you see the Madgwick wrapper. So this wrapper was generated by us when building the S function builder. Yes, so let's take a look inside. Okay, so here we have the wrapper, and here we have called the Madgwick function, which is this one. Yes, so basically let's put a breakpoint at the end of this function. Yes, and just press play. Okay, so it stopped here. This means that we have called this this function, and the output it's stored, as you can see here in the last code here in Q0, 1, 2, and 3. So this is the output. So this is, because it's a global variable, we will store it to this Qt 0, 1, 2, and 3. Okay, good. So let's put a breakpoint here and press. So good, it stopped here. Now we have the values here. Yes, good. After this, we move on to the output. So as you can see here, we have word display data, which is a custom function, also included as an MPT signal, but the direction is output. Yes, so here we only have an printf, which will send the data to our via word, and we can visualize it in the PuTTY. So there is not much to do here. So we reached the goal for today for having an external source code integrated in Simulink. Okay, so if you have some questions, please address them in comments, and yes, I will try to answer as soon as possible. Okay, so again, we have here the output. Thank you very much, and I hope that this will help in sometimes. Bye.